Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps and the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so this feels like quite a big question for the first question on a foundation paper. And you would be right to think that. This is a practice paper, remember? So it's just all about getting the revision in. Because these particular sets that I'm doing are from the early stages of this GCSE, some of them can be a little bit different to what we see these days. But that, again, shouldn't be putting you off. There's always those questions that you think, God, I've never seen that before. These practice papers are so, so good for preparing you for that. So do get stuck in, don't be put off. Okay, so this question is just really, once you've read through it and you get to this stage, write the fractions in order of size. It's just putting the fractions in order of size, starting with the smallest. So let's just list these out quickly. Now, in order to be able to efficiently and correctly put these in order, I want to write equivalent fractions so that the denominators are all the same. To do that, I've got to consider the denominators I have, which is 2, 5, and 4, and think of a times table that they all go into. I want the first and kind of lowest multiple, and that would be 20. So the first fraction I'm going to times through by 10 in order to get that 20 on the bottom. But whatever I do to the bottom, I do to the top, and that would be my equivalent fraction. I'm then going to repeat the process, multiplying through by the table that is going to create a 20 on the bottom. Now I've done that, I can see clearly that 8/20 is the smallest, which came from 2/5. So I'm going to write 2/5, and I'm going to continue to write them in order using the original fractions. And we're done. Okay, we need to work out how many pencils we can get from the £10. Now, the first thing to note really is the fact that you've been given £10 and you've been given pence. We have different units and we need to be in the same units. So I'm going to change my £10 into pence, which is going to give me 1,000. And I want to work out how many 80 pences I can get into that. So it's a divide question. Now, the first thing I can do is divide the whole thing by 10. I don't want to work with such large numbers. If I can avoid it, I will. So that is going to cancel off of both. Then I can just go straight in to my bus shelter. So 8s into 1 don't go, carry the 1. 8s into 10 go 1, remainder 2. 8s into 20 go 2. And then I've got a remainder of 4. At this stage, you'd put your 0, put your point, and you can keep going. 8s into 40 go 5, or you can stop, because actually he can only buy whole numbers. So even if it goes into the decimal, we don't really need it. We already know it's 12 as a maximum. Okay, m plus m plus m plus m is 4m. If we take 2 A's away from 5 A's, we have 3 A's. And then we don't show the time sign, we just squash everything together. Okay, so for 4A, this really is an English sentence that they want you to write down. Okay, now the main thing that I want to point out here, because it seems like a very simple question, but I see it going wrong a lot, and that is the use of the word and. When we say that number, we say 4,117. And I often see that missed, and then the mark's gone. So really, really remember exactly how you say it is exactly what you write. So to the nearest 100 means we would cut it here. 2 zeros are in 100. So you pop those underneath the digits and cut. The 1 is not big enough to have any impact here. So our final answer is 4,100. Okay, so we have got a number from one box and a letter from the other. And we've got to list all the possible outcomes we could get if we just did that blind. So if we got the letter A, it could go with 1. It could then go with 2. It could then go with 6. And then it would be the turn of the C and then the E. And doing it in a kind of systematic way like this does help you not miss any out. We've then got to find the probability that David takes the number 2 and the letter E. So the number 2 and the letter E is there in our list. So there's 1 out of a total of 9 combinations. Okay, so we're being told that Mitch only has these 3 coins and no other money. So basically, Mitch has got £4. He wants to buy a chalk ice, a tub, and 2 cones. And again, if I was to say where the error might happen in a question like that, it would be there where people just do the 1 cone. They kind of forget it's going to be 2. So we've got a chalk ice for £1.25. We've got the tub for £1.15. Now you could pause, add that, get a total, and then add your 85, or you could do your 2 cones at 85 pence into the same question. It really doesn't matter how you do it. So 5, 10, 15, 20, we're carrying that 2. This adds up to 21 and 4. So the total cost is going to be £4.10p. So the answer is no. And don't forget to answer that question. Okay, Jack and Max share some counters. Jack has 3 times as many counters as Max, and we've got to write down the ratio. So we've got Jack to Max. It's really important that we put it in the right order. Jack is being mentioned first, and then it's Max. Jack has 3 times as many. So Jack will have 3, and Max has 1. And any multiple, so if you'd worked it out and said it was 6 to 2, you'd be correct, okay? This is it in its simplest form, and it's the most likely result people will have put down. Now, what fraction of the counters does Max have? So Max has got 1, and when Jack has 3, that means between them there's a total of 4, and that is why it is out of 4. Now, again, if you did an alternative, you may have done, say, 2 out of 8. Here, I would really encourage you to cancel. To be honest, I would encourage simplest form throughout because it's going to guarantee 100% the mark. We're not kind of taking any risks. So Sunil has 40 counters, 9 are red. What fraction are not red? Well, first thing we need to do is work out how many are not red. So 40 take away the 9 is 31. So 31 out of 40 are not red. Okay, this is a 3-mark question, so they're going to be expecting quite a bit of working out. That is, in essence, why you've got this here. Because you could just go, which is bigger? Oh, God, I don't know, and boom, guess. If you do that, you're not going to get any marks. When you're being asked to justify, even if you've got the answer right through guessing, they're going to kind of think that's what you've done and then not give you the mark. So we've got 2/5 or 0.6. Now, what is 0.6 as a fraction? It is in the tenths column, so it is 6/10. I am now going to divide this down by 2, which is 3/5. And then I can see that 3/5 is bigger than 2/5, so it was 0.6 that was bigger. And you don't have to do it by putting them into fractions. You could have done it by putting the 2/5 into decimals. So if you knew that 2/5 was 0.4, or you were prepared to do 2 divided by 5 to work it out, then that would have been a perfectly acceptable route as well. But do remember your place value grid, your hundreds, units, tenths, hundreds. It can come up in these types of questions and be very, very useful. Okay, a very wordy probability question, which is the norm. Probability is generally wordy because they're trying to create a story for you. So in this case, we've got red and blue counters in a bag, and there are 4 red. The probability of taking a blue, so the other color that we don't have a number for, is the same as the probability of taking a red. Now, if it's the same, then there must be an equal number in the bag. So there would be 4 in the bag. In another bag, and again, that's quite key because sometimes it's really easy to want to carry on thinking about the first part of the question. So in another bag, so completely different story, there are 14 counters. It contains red, blue, and yellow. 4 of the counters are red. So I'm going to set this up, kind of code that whole sentence out. I do not want to be working in words. I like codes, I like symbols, I like diagrams, but I don't like long sentences. So I've got my red, my blue, my yellow, 4 are red. There it is. That is that sentence more mathematically written. Now, the probability of taking a blue counter is twice the probability of taking a red. Okay, well, my red is 4. So if the probability is twice, there must be twice as many. These 2 add up to 12. There's a total of 14. So there must be 2 yellow. So the name that we give to this quadrilateral where it's got 1 set of parallel lines is a trapezium. Measure the angle marked X. So we should be putting our protractor into this corner. And the answer is 60 degrees. Now they do allow on this mark scheme a tolerance of plus or minus 2 degrees. So if you're out by 2 degrees, you will get the mark. And the name for angle Y is obtuse. Obtuse is for all angles that are greater than a right angle, but are below 180 degrees. Okay, our next question is reading timetables. So we're being told that a bus goes from Harrow Lane. So here is Harrow Lane at 8:02. So it's this bus What time should the bus get to Cartbridge Street? Cartbridge Street is here. So you just follow it down and you get that time. Okay, this time the timetable is from Cambridge Street to Harrow Lane. So we're kind of on the return journey, so to speak. We're told that the bus goes from Cartbridge Street to Harrow Lane. This bus, so this same bus, leaves Hampden Road at 13:29. So we've got Hampden Road at 13:29. Work out how many minutes this bus should take to go from Hampden Road to Elm Drive, which is basically the next stop. So the time is 13:29, and we need to know how many minutes it's going to take. Now, I'm just going to add 1 minute just to get it to past, so 13:30. And then I want to get to 13:43. To get from 30 to 43, it's another 13 minutes. So in total, it is 14 minutes. Okay, we've got a lot of detail about Peter's journey. I've put the timetables onto obviously the page next to the question to make it easier to explain how we do this. The best way to do it is actually to do it backwards. The only time that we've been given in the question is when he needs to be back home after his day with his grandmother. Now, I don't like all these words. I'm going to first of all plan this out and just abbreviate it. So we're going from Harrow Lane to Swipe Crescent. We're going to spend 3 hours. And then from Swipe Crescent, we're going to go back to Harrow Lane. And we've got to be there by 1600 hours. Now, if I'm going to do this backwards, I'm going to start with the SC to HL. So that is the second one. Swipe Crescent to Harrow Lane. I have to be in Harrow Lane by 1600. Now, this gets me in too late. This one gets me in with plenty of time. So this is the bus that I want to be on, which means I am catching it at 15:16 and I'm getting in at 15:49. So that's part of my journey. Now think about the 3 hours. It's 3:15, pretty much. So count backwards. 2:15, 1:15, 12:15. That's kind of my key time to think about. It's not the perfect time, but that's my key time. I need something around that time to make everything work. I'm going to look at my Harrow Lane to Swipe Crescent. I want to be in Swipe Crescent by 12:15, absolute latest. So I'm going across. 12:45 is 12:43 is too late. So this is the one that I want to be on. That's going to give me plenty of time with grandmother, which means I'm leaving at 11:02. So now I'm going to set this up to make it clear for my examiner. I'm going to leave Harrow Lane at 11:02. I'm going to arrive at Swipe Crescent at 11:41. I'm going to have my 3 hours. In fact, I'm going to have a little bit longer. I'm then getting on the bus at Swipe Crescent at 15:16 and I'm home by 15:49. Okay, so Ravi drives for 4 hours at an average speed of 30 miles per hour. That means he's doing 30 in 1 hour. We want to know what he's going to do in 4. So it's 30 times 4, which is 120 miles. On Tuesday, Ravi drives 200 kilometers, and we're being told that there are 5 miles in 8 kilometers, and we want to work out which day he drove further. So we've got a fact. My facts always go into my grid side by side. I'm going to label it up so I'm not forgetting which number's which. My third number is 200 kilometers. So in my kilometers, we are going to pop that in. Then we multiply across and divide by the trap number. So 5 times 200 is 1,000. And 1,000 divided by 8. So 8 into 1s don't go. 8 into 10 go 1, remainder 2. 8 into 20 go 2, remainder 4. And 8 into 40 go 5 exactly. So it's 125 miles on our Tuesday, which means Tuesday, that's the answer, was further. Okay, we've got to draw pattern number 4. The best thing to do here is just to clock how it's growing, then copy the third one and add on that growth, okay? So if I look at pattern number 1, pattern number 2 was found by adding these 3 on the end. Then if you look at pattern number 3, this is pattern number 2, and these are the 3 that have been added. So pattern number 4 will be the same as pattern number 3, and then you just add on 1, 2, 3. Okay, we're being asked to complete the pattern. Now, pattern number 1 had 4 sticks, 2 had 7, 3 had 10. We can count our sticks, or we can actually start spotting that there's a pattern here. To get from 4 to 7, we add 3, and we saw that physically when we drew it. So I can just keep adding 3 to complete this. So that gives me 13. But then I hit a bit more of a problem. This isn't pattern number 5, it's pattern number 10. Now, it's not going to be much of an effort to just keep adding the 3 until I get to the 10th number, or I can use a formula that will help me. Now, part C is asking for an expression in terms of n for the total number of sticks needed. The way that you do this is you look at what it's going up in, which we've done here. It's going up in 3s, and you squash that to the n. You would then go backwards to see where that takes you, and it takes you to +1. And that goes on the end. Now, we're used to doing this when the pattern is in a row. So I'm going to show that to you again, just so you can see it in a row. 4, 7, 10, 13, on and on it goes. It's going up 3 each time, so it's 3n. Go back 1 term, so do the opposite, take away 3, you're at 1, that is +1. Now, the reason that I'm wanting to have this a little bit earlier in the question is because the rule fits a pattern, answers more complicated questions. So yes, question number 10, you could keep going and get your answer. Nothing wrong with that, absolutely fine. Or you could say that my pattern number, my n, is 10, and 3 times 10 plus 1 is the maths to find the number of sticks, which would be 31. It can really help with this one where we don't know the pattern number, but we know the sticks. We know the sticks can be found by doing 3 times the pattern number plus 1. And in this question, the sticks are 76. So now all I need to do is get n on its own to find out the pattern number. So I'm going to take away 1, which is 75. So I've got 3n equals 75, and then I divide through by my 3. So 75 divided by 3, 3's into 7 go 2, remainder 1, and 3's into 15 go 5, 25 being the answer there. That last one in the table is definitely very, very tricky. Okay, so we've got a bus leaving a station every 24 minutes to go to Acton, and another one is leaving every 20 minutes to go to Barton. Now, these buses are leaving the station at the same time at 9 a.m. And we've got to work out, as they're doing their kind of loop, when the bus to Acton and Barton will leave the bus station at the same time. Now, we want to really not worry about the time to start off with. Rather, we want to just work out how many times the bus is coming back. So the first thing that we're going to do is work out when the Acton bus is at the station, and that's going to be every 24 minutes. So we've got 24 to do its loop. Another 24 means 48 to do the next loop. And then we just keep adding. 4 plus 8 is 12. I'm carrying 1 in my head. 2 plus 4 is 6. We've got 72. And then I'm going to repeat that. 4 plus 2 is 6. And 2 plus 7 is 9. Then I'm going to repeat it. 4 plus 6 is 10. Got that 1 in my head. The 9 and the 2 is 11 plus the 1 is 120. Now, the reason that I've kept going and going and going is because I've also got in my mind the fact that the other bus is every 20 minutes. So I'm really keeping going because I'm trying to find a number that would go into 20. And that one would. So the other one is 20 minutes, 40 minutes, 60 minutes. I could list them all out, or I could see that I can double my 60, which would take me to 120, giving me the first time they both come back. Now, 120 minutes is equal to 2 hours. They left at 9 a.m. So when I add my 2 hours, it will be 11. And then don't forget your units, 11 a.m. Okay, expand and simplify. So the expand stage is just to multiply out the brackets. And then the simplify is to bring those x's together and those y's together. So we've got 2x plus 4x, which is 6x and 6y. And be really careful, make sure you're clocking that sign in front of the number. It's -4, take away 4. So 6 take 4 is 2. 2 is a positive number, so plus 2y. And then factorizing is doing the opposite. It's putting the brackets back in. So you're looking to see what is common in the terms. So in the numbers, 8 and 12 are both in the 4 times table. Now, you could say it's in the 2s as well, and you wouldn't be wrong, but you must always choose the highest times table. So that would be 4. P is common in both. So you pop your P down and then you open up your bracket. I want to put something in here that when we multiply it by this on the outside, it will create 8p. So 4 times 2 creates the 8. And the single p is already on the outside, so we don't want to do any more than that. And then I'm going to need 3 to get the 12. The single p is already on the outside, but I need a q, so we attach that. And that is the expression factorized. Okay, so we need to find the highest common factor of 30 and 42. Now, these numbers are quite low. They're in tables that we have learned and understand, and actually just finding the factors will help you find that highest common factor. I am going to demonstrate a slightly different method just to remind you that it's available to you. Obviously, it would work here, probably more work than you need to do if I'm honest, but equally, I just want to take the opportunity to remind you so that if the numbers weren't as kind, maybe it was to find the highest common factor of 42 and 190. I don't know, I'm making it up now. But if they were numbers that were a little bit trickier, then this method really would work nicely. So what we're going to do is just find the prime factors, which doesn't take very long at all. And then we're going to pop them into a Venn diagram. 2 and 3 are in both. So that leaves me 5 and 7. The highest common factor is the middle section, 2 times 3, which is 6. If you're confident with this, I actually don't think it takes any longer than finding all the factors, but that is one way to do it. Now we need to find the lowest common multiple of 30 and 45. 45 is a different number, so don't think you're working with the same Venn diagram. You could work it out using the Venn diagram, and then it is all the numbers that you multiply for the answer, or you can just do lists. If you choose to do the list way, I would always list out the larger of the two. So what we're doing is we're going to write some of the times table. So 45 and then 90. And before I carry on, I'm going to always consider Could the number I've written be in the times table of the second given number? And I can see straight away it will be. So this one really is very, very simple. 90 is the first number to come up in both times table and therefore is the lowest common multiple. Okay, we've got to find the volume of the prism, and it's made by cutting a solid cube of side 2 centimeters in half. There's different ways to do this, but if the cube is 2 centimeters, which they are telling us, that means we're 2 centimeters that way. That means that each one of these is worth 1 centimeter. So it's like a 1 centimeter cube that's been put together with lots of cubes. I've got full cube here, I've got half a one here, and I've got half a one here. That adds to give me 2. I can see we've got 2 going back. So it's 2 times 2, which is equal to 4 centimeters squared. And again, if you look at the dotted line, there are no units, so you must do this. Now, it's not the only way to think about this. I could, and I'll do it in blue, I could have just said, okay, I can see a triangle. I can see its height is 2 and its base is 2. So I can do 2 times 2, which is 4. Divide that through by 2, which is 2. That's the area of my front face, my triangle. And then I can times that through by 2 to get the 4. Okay, so this was a really tricky question, and it is hard. There's no easy way to get around this other than to do the maths the long way. So I'm going to just do my calculator method and work it through by hand. Okay, so I'm trying to work out the greatest number of shortbread biscuits I can make with the ingredients that I have. So I'm going to need to work out the maximum that butter can make me, and then caster sugar, and then flour. The fact that I have to help me with the butter is that 120 grams is going to make 8 biscuits. So I pop that into my grid. My fact is always at the top, side by side. The information that I've got for butter is that I have 330 grams, not 120. Okay, so I want this to work for me, being non-calculator. I know that I always divide by the number in the corner here. I can divide 330 by the 120 or the 8 by the 120. And I'm going to set the 330 divided by the 120 up because obviously they both have that 0, which means I can straight away cancel this down to 33 over 12. And I times through by the 8. So I'm going to times through by the 8 first. And then I'm going to divide through by the 12. Now, at this stage, I do have some left over. 12s into 14 go 1, remainder 2. But I'm trying to work out the greatest number of shortbread. So it doesn't matter that it carries on and there's a little bit more I can make of a biscuit. I just know that butter is going to make me a maximum of 21. And that's all I need to know. So I can stop there. So that's my butter done. And I'm going to repeat the process with the sugar. So the fact is that 8 biscuits can be made from 60, and I've got 200. I'm going to set my 200 divided by 60. Now, with this one, I can cancel through by 10, but I can also half. I can also divide by 2 to get me an even simpler fraction. So 10 over 3 times 8. So 10 times 8 is 80, and then I just need to divide that through by my 3. So I can get a total of 26. Now that doesn't matter that that's greater. I don't have enough butter to make 26. So 21 at the moment is the greatest number that I can make, but I've got to check in with the flour next. So my fact is that 8 shortbreads can be made from 180. I've got 450. setting it up in exactly the same way, dividing through by 10. And then I can see that 45 and 18 is in the 9 times table. And that takes me to some very straightforward, nice, easy, low numbers. You might notice that they're in the 3 and divide by 3 and then realize you can cancel again. It doesn't really matter. But if you can cancel the fraction, you're making the maths way easier for yourself. So 5/8 are 40. Divide that through by 2 and 20. Now that is smaller than the amount I could get from my butter. So this is the greatest amount that I can make. So 20 would go on the dotted line, and I've got all the working as requested. It isn't the only way, but I couldn't find, for me and for the way that my students work, a better way in. So it was a lot of work. Okay, we've got a probability question. These are super common in the exam, so a really good topic to target and get good at. So we have got our story. Remember, probability questions are usually quite wordy because they like to give us a story. So Wendy's at the fair. The probability that she wins at Hoopla is 0.4. And we can see that they've already put this on for us. There's Wendy winning at 0.4. So if she's not winning, it will be 0.6. And then the coconut shy to win is 0.3, so to lose is 0.7. Whether she wins or loses at Hoopla, it really makes no difference to whether she wins or loses at the coconut shy. So this is repeated. We've then got to work out the probability that Wendy wins both Hoopla and coconut. Now that is her starting her day at the fair, let's say. Here she is winning, and here she is winning again. Now that pathway across the diagram gives us these 2 decimals. So our job is to take those decimals and multiply them. So we multiply to get the answer. 4 3s are 12. And then we've got to consider where the decimal is going to go. It's going in one place for the 4 and in one place for the 3. So it's going to go in once, in twice. It's going to end up being here at 0.12. If you are tempted to do that, or if you did do that and you're checking your answer, this is an alarm bell straight away because it's over 1. Probability is always between 0 and 1. So that there would make you stop and think, hang on a minute, that doesn't fit the rules of probability. Okay, so this is another really tough non-calculator question. The normal approach that we take with percentage questions on non-calculators is to find 10% and manipulate it. If I do that here with rail tickets, if I started off finding 10% and then halving for 5% and halving for 2.5%, I'm not getting to the 2.25 that I want. And actually, the way that this is worded is really important for me to clock as well. 2.25% of the ticket price is something that I can write mathematically. 2.25, so that number, and then percent means out of 100. So that's the percentage sign written mathematically. Of means times. So that's my of. And then, of course, my ticket price is 60. So that entire sentence can actually be written mathematically. I've got a fraction to multiply into a whole number. If I wanted to, I could take that whole number and put it over 1 so that I could see it almost as multiplying fractions. And then it's a just do it question. If we are confident about multiplying fractions, we will know that we can cancel down denominators and opposite numerators. If we're not confident about that, then we would have to do 2.25 times 60 and then divide the answer by 100. But this will make the numbers work a little bit more in our favour. I could actually divide by 20 and cancel that right down to 3. And obviously, what I do to the top, I must do to the bottom. And that would give me 5. That completely changes what I'm looking at here. I've now got 2.25 over 5 times 3 over 1. 2.25 times 3 is 6.75. Now, if you can't see that it would be 6.75, you can just put it on top of each other and add it up. And 5 times 1 is 5. So I now need to work out how many 5s are in 6.75. So that's going to go into my bus shelter. So 6.75 divided by 5. 5s into 6 go 1, carry the 1, but there is a point, so bring it up. Then it goes 3, remainder 2, and 5. So 2.25% of the ticket price is £1.35. There's also that booking fee of 80 pence. So 1.35, add on the 80, and we've got a final price of 2.15. Now we're going to do cheap trains. They're charging 1.5% of ticket price. So here we go again. 1.5 over 100 times 60. Put it over 1. Cancel it through. 3 1.5s is 4.5. And we're going to divide that by 5. So 5s into 4 don't go. Carry the 4. Put that point up though. And then 5s into 45 go 9. So this would be money-wise 0.90. Their booking fee is £1.90. So you add that up and you get £2.80. So the charges would be your ticket price 60 plus £2.15 here or £2.80 here. So we want to go with rail tickets. Okay, I'm going to write this number in standard form. Now, standard form is 1 digit with value and then the point. So it has to have the decimal point between the 3 and the 8. I'm going to count that into place. So that's 1, 2, 3 is my movement. So we're timesing by 10. The power will be 3, but remember, this is a small number, so it will be -3. And then we're going to kind of do the opposite for writing the ordinary number. We've been told it's times 10 to the 5. It's a positive 5, so it's a big number. So I'm going to take my 7.291 and I'm going to count 5 places in this direction because I want to make the number bigger. So we're going to go 1, 2, 3, 4, 5. I've got 2 empty buckets, which I'm going to fill with zeros. And that would be my final answer, 729100. I've now got to work out this calculation. It's a divide question, and I've got to give my answer in standard form. I'm going to start by doing the number work. I've got 2.4 that I have to divide by 6. Now, I don't have a calculator. So what I'm going to do is I'm going to multiply this up by 10 to get rid of the decimal to start off with. That's going to give me 24 over 60. And then I can start cancelling this down into its simplest form. I can look for which times tables go into this, or I can just half it, get the numbers a little bit smaller and easier to manage. Again, I can go higher, but it's even, and I could keep going like this if I wanted to. That divides through by 3. 3s into 6 go 2. And 3s into 15 go 5. But this does give me a fraction, which is not ideal for standard form. So I've now got to do 2 divided by 5 to get my decimal. So 5s into 2 don't go, which we want to happen because we know it's going to be a decimal. So there's 2 left over that we've not used yet. Add the 0, add your decimal point at that stage. 5s into 20 go 4. So I've got 0.4 times and then I've got to do my 10 to the power. So let's quickly look at the powers. We've got 10 to the power of 10 that we have to divide by 10 to the negative 2. When you divide powers, you take away. So it would be 10, take, negative 2. Got to be really careful there because we're getting a positive to create 12. So that's our missing power. We do have a problem, however, because standard form should always have its first digit with value, and this does not. So really, I'm going to need to move the decimal point this side to create 4. By doing that, I've actually made the number bigger. I've multiplied it up by 10, basically. But it means to compensate that, I have to make this smaller, just by 1. So it goes down by 11. And technically, the opposite's happened. I've multiplied by 10 to get the 4. I've divided by 10 to get the 11. So our final answer is 4 times 10 to the 11. Nice and clear there on the dotted line. Now, that would be the way that you might work through the problem if you're not massively confident when you see something like this. We are taught in class that we never combine our decimals and our fractions. But let me just show you, in this case, if you were confident, you could have just kept it in that form of 2.4 divided by 6. You could have done that whole cancelling the fraction, which would have given you 1.2 over 3. And then you could have gone into your bus shelter. 3's into 1 don't go. Bring up the decimal, carry the 1. 3's into 12. And look how much faster I got to that 0.4. That literally just comes down to our confidence level in manipulating with decimals and fractions. It's not essential to know this. We can go with what we may already feel comfortable with. Just wanted to share that so that you were aware it's not just this way and the only way. Okay, so for the first bit of this question, we need to work out the real distance between the castle and the church. So we would draw our line that we need to measure on, get our ruler and measure it. Now, with this type of question, your measurement might be slightly different to mine, because of the fact that you've downloaded the paper, you've printed it, your printer settings might be slightly different, and therefore your line will be different. So if you've measured it differently, but you followed the steps, then you know you're doing the right thing. On the real GCSE paper, it is 8.2 when you measure it, so 8.2 centimetres. We've been given the fact here that the scale of the map is 1 to 10,000. So 1 to 10,000 is my fact. It's gone in side by side. The 8.2 is going in this side. So for every 1 on my map, it's this in the real world. The real world will always be obviously much bigger. This tells me to multiply through the diagonal, divide through by 1. Dividing by 1 isn't going to change anything, so it really is just multiplying by 10,000. That is going to give us 82,000. Now, it does say give your answer in meters, and obviously we've measured in centimeters, which means this is in centimeters. So we're going to divide through by 100 and we've got 820 meters as our final answer. Now we're being asked to work out the bearing of the castle from the church. That means we are at the church and we are going to travel to the castle on this bearing. So that's the angle that we have to measure. And we literally just do that with a protractor to get our answer of 130 degrees. And that's it for this non-calculator paper. It was pretty tough in places, so I hope the work solutions have helped you if you've made any errors along the way. Remember, you are learning and errors are taking you out of your comfort zone and are going to be helping you make progress. So never get too frustrated if you can with that happening. It's all normal. It's all part of the journey. So the next one that will come out will be the calculator paper. We'll do paper 2 followed by paper 3, and then this set will be done, ready for us to start working on the next one. So do subscribe and like if you are finding these useful, and then you will see them land as in when we get them done.